if the problem given is just like x of n is equal to 1, 3, 5, 3, 1. So find the DTFT of the signal x of n is equal to so. So this indicates, as x of n is in this way, this arrow mark indicates the 0th value. Means 5 is taken at 0th place. Let's represent the signal in this fashion. Let this is equal to 5, 3. So 3 would be on the positive side. It is a bit less than 5. 3, 1. So 1 would be this one. Then 3 at -1. So this indicates -1th position, -2. So at -1 it is 3, and at -2 its value is 1. So in this way the signal is to be drawn. Then the value of x of e raised to j omega, x of e raised to j omega is equal to summation n from -infinity to +infinity x of n e raised to minus j omega n. Now next we know that the signal is not running from -infinity to +infinity. So for this problem it is from n is equal to -2 to +2 x of n e raised to minus j omega n. So now we need to go on substituting the values of n. So when n is -2, so we can write this one as x of -2 into e to the power minus j omega -2 plus x of -1 e to the power minus j omega -1 plus x of, so in this way it is x of -2 e raised to j omega, minus of minus, it would be +2, x of -1 e raised to minus j omega, n is -1, so it is j omega. X of 0 e to the power of n is 0, means we get 0, e to the power 0 is 1. So x of 1 e raised to minus j omega into 1, and x of 2 into e raised to minus j omega into 2. So when we substitute, x of -2 is equal to this value, it is 1. X of -1 is 3, x of 0 is 5, x of 1 is 3, and x of 2 is 1. So when we substitute these all, we get a, so this is 5, and this e to the power of j omega is expanded to, so by using these two terms, 3 into e raised to j omega and 3 into e raised to minus j omega, if we can divide it and multiply by 2 by combining these terms, so we can write it as 6 into cos of omega, and even the same with this j 2 omega, so we can write it as 2 into cos of omega. So at omega is equal to 0, its value means, let's put omega is equal to 0. When we put omega is equal to 0, we get 13. Even by putting omega is equal to 0 in this equation also, we get the value as 13. finding DTFT of del of n. So here x of n given is del of n. When we have x of n as del of n, we write the equation x of e raised to j omega, the analysis equation. So when we write x of n as del of n, we know the del of n signal. The del of n signal is existing only at the 0th instance and it is not existing anywhere else. So this equation becomes, instead of writing the summation, we can write this is equal to 1 when n is 0 and it is equal to 0 when n is not equal to 0. So x of e raised to j omega is del of 0 e raised to 0. So its value would be 1. So which will be represented in this fashion, same as the Fourier transform, where the Fourier transform of del of t was equal to 1, and similarly Fourier transform, discrete time Fourier transform of del of n is equal to 1. Then another important example is the DTFT finding of a rectangular pulse. So x of n is equal to 1 over the magnitude of n is less than or equal to m and is equal to 0 for magnitude of n greater than m. The meaning is there is a certain range. There is a certain range, and if n is within that m, then its value is 1. So which can be represented in this fashion. So we can represent that signal in this fashion, just like a rectangular pulse, but it is not periodic. So let's say this is minus, it is m, and this is m. So when magnitude of n, the signal says that when magnitude of n is less than or equal to m, less than or equal to m means this n, our axis is always, now this axis is n. So as long as the magnitude of n is less than or equal to m means, but this becomes a continuous signal, the meaning is same. So we can imagine the values like n is equal to -1, -2 and so on. So like this. So n can be -1, -2, -3. It can be anything. We can have few samples over here. There may be any in number. But it is not a continuous signal, it is a discrete signal. For such signal, let's find what is the DTFT. So we use this equation n from -infinity to +infinity, x of n e raised to -j omega n. But we know that the signal is 1 only in the duration m. So it would be n from -m to +m. It is the value of x of n is 1 e raised to -j omega n. And to make this lower limit as 0, so let's take the value, let's take L is equal to n plus m, because we need to make it as 0. Then when n is equal to -m, this L goes 0, and when this n is taking m value, then this m plus m to n. So we get e raised to -j omega. Now n is nothing but L minus m. And here we know that the summation is with respect to L. M is independent of the summation. So this term e raised to -j omega and this -m will make it as plus e raised to j omega m is taken out. And only with this L term we write this summation. And we know summation n from 0 to n minus 1 alpha raised to n is 1 minus alpha raised to n 1 minus alpha. This equation we have used already, and this is equal to n, means n minus 1 upper limit minus lower limit plus 1 is equal to if alpha is equal to 1. So that is the very first problem in convolution. We have used this equation. Then by substituting, this e raised to j omega m remains as it is. We get 1 minus e raised to minus j omega into, now by substituting, let's solve this problem. So by using this equation, we can write this one as is equal to e raised to j omega m as it is over the bracket. So this can be expanded with this term. So it is 1 minus alpha is nothing but e to the power e minus j omega L. In place of this n, L is there. So let's write this one as, now if n minus 1 is there, it would be n. Now here we have 2m. So it becomes 2m plus 1. So it is 1 minus e to the power minus j omega 2m plus 1 divided by 1 minus, that's it, e to the power. So except this, just alpha we need to write. Alpha is nothing but e to the power minus j omega. So we'll write this. And to solve this one, what we can do further? So here we have 1 and e to the power minus j omega 2m plus 1. So what can be done so that this can be? So let's take from this term, from this equation, e to the power j omega as it is, e to the power j omega, this m is as it is. From this term we take e to the power j omega into 2m plus 1 divided by 2. So from this, e to the power minus j omega 2m plus 1, half of this value we take it outside. So when we take half of this value, what remains in the bracket? So here this becomes, as 1 is there, we have taken this common, means this gets divided over there. So it would be e to the power j omega 2m with a plus sign 2m plus 1 divided by 2, it is e to the power. Then minus, as we have taken half of this value outside, so the same value remains, e to the power minus j omega 2m plus 1. And from the denominator also we take e to the power of this half, e raised to minus j omega by 2 outside. Means let's write it as e to the power minus j omega by 2 outside. When it is outside, this becomes e to the power of j omega by 2 with a plus sign as this one, and minus e to the power of j with a minus sign j omega by 2. Now for these we can go for writing the sinusoidal terms. So e to the power of j omega minus e to the power of minus j. So to this we need to take 2j as in the denominator, and even this is e to the power j minus e to the power of minus. So we need to take up 2j and 2j to write them as the sinusoidal terms. And when we go for solving this e to the power of j omega 2m plus 1 divided by 2 So here minus sign is there. 2m divided by 2 is nothing but m. It gets cancelled, and e to the power of minus j omega gets multiplied with this plus 1 and this. So this whole term cancels. So this goes to 1. Check it after solving. So this, when you expand, this all cancels. So what we are getting is, it is sine of, so we can write this one as, by considering this 2j, sine of omega 2m plus 1 divided by 2. And for this, so by considering this 2j, we can write this as sine of omega by 2. So next we need to solve it by using the sinc function. As we are solving it by using the sinc function, so we know the sinc function from the last things. So sinc of u, this resembles the sinc function. So we can divide this one by 2 pi by 2 m plus 1, and to compensate that one, even we can multiply by 2m plus 1, 2 into m plus 1. Similarly, we can go for this omega by 2 is there. To get it to the sinc form, we can multiply it by 2 as to make this one as 2 here, and even omega. So this becomes omega is equal to 2. This omega is 2. To make this denominator and numerator equal, sine of, just to the bring it to the form sinc of u form, so we can multiply by 2 here, and we can multiply by omega over here, and even we can multiply by this omega, and 2 is there, this omega, to compensate, to make this one as the same as numerator, and the same we can multiply. So as we have multiplied here, omega is equal to 2 divided by omega we have done, and to compensate that one, we have to again write it as omega by 2 similarly, and this is omega, this we have compensated, 2m plus 1 we have compensated, this 2 we have to compensate, and when we cancel this 2 omegas and the extra ones, so we get the sinc function remaining with 2m plus 1. So its value is 2m, this value is x of e raised to j omega. So the value of x of e raised to j omega is equal to 2m plus 1 for omega is equal to 0, for it is equal to 0, 2 pi plus or minus 2 pi, etc. This way it continues. So let's say the same thing here. So this x of e raised to j omega is written as sine of omega by 2 to m plus 1 divided by sine of omega by 2, which represents, after readjusting the sinc functions, just we have to assume and draw the output. Then how we can draw the output of this? Just I'll give you the hint, then we can view the output. So this is our axis, and let's say this is a 0 and this is our omega. Then when omega is equal to 0, as it says, its value is 2n plus 1. So it is by using the sinc function as we know. So let's draw it. So the sinc function will be in this form. So it is this way. It is a 0. Then its first value the first zero crossing will happen when this all equals now omega 2m plus 1 divided by 2, when omega 2m, when omega 2 into m plus 1 divided by 2 is equal to pi, when this is equal to pi, we have the zero crossing. So let's make this one as when omega is equal to, this implies that when omega is equal to 2 into pi divided by 2m plus 1, means the zero crossing will happen when omega is equal to 2 pi divided by 2m plus 1. So this first crossing will happen when omega takes this value. Similarly, when omega is equal to minus of 2 pi by 2m plus 1, it takes the first 0 on the negative side. So this will be the nature of the output, and 2m plus 1 is the highest value, 2 pi by 2m plus 1 is where the first crossing happens, and depending upon the value of m will be having the next cycle. And it has been noted that when omega is equal to pi, when omega is equal to pi, this equation becomes sine of pi by 2 into 2m plus 1, and we know that when pi by 2 is the angle, sine will be maximum, so it is represented in this fashion. So it is not having a zero value at that place, and otherwise if this pi by 2, this 2 was not there, then the things could have been a bit different. And then again it goes on increasing again when omega takes a 2 pi value on the positive side, again a positive peak is observed similarly in the negative cycle. So definite number like here 1, 2, 3. So we need to draw like 2 or 3 depending upon the value of m. As we don't know m, so we are representing some even signal, like how many we take on this side, the same we have to take it on the other side. So in between 0 to minus pi, how many cycles are there? The same number of cycles should be there in between minus pi to minus 2 pi. So this is regarding this problem. So this problem was asked 2-3 times in the exam. So let's see this. Let's see another problem, that is alpha is to n sine of omega naught n into u of n, where alpha is less than 1. So we substitute this value, and in these kind of problems we go for expanding the sign. So sign is e to the power of j omega naught n minus e to the power minus j omega naught n divided by 2j, and we take this common, alpha is to n, and we write alpha and e together with j omega naught n. So by arranging, we can write this one as j omega, this omega minus omega naught. So minus sign is there with alpha, as well as this alpha raised to n is there. To write this alpha e to the power minus j omega minus omega naught we write, and the same this minus sign alpha e to the power minus j omega is there, and this will, so omega plus omega naught. So when we write this, so by using that summation, if we have n is equal to 0 to infinity and this value, so we write this one as 1 divided by 1 minus whatever is there to the power. So it is 1 minus alpha e to the power minus j omega minus omega naught, and similarly 1 by 1 minus alpha e to the power minus j omega plus omega naught. And after solving this one and multiplying these two, so we get this term. So the same kind of problems will be there in the Z transform. So please consider this one with serious, and this will be regarding the discrete time Fourier transform.